Hi there, I'm your explainer, and today in this video I'm going to explain about how AI is helping out NASA for the exploration of the red planet. NASA rover use two instruments for detection and analysis purposes, AI and the PIXL instrument. Rover is investigating a region of Mars where the ancient environment may have been favorable for microbial lives, probing the Martian rocks for the evidence of past life. The rover carries an entirely new subsystem to collect and prepare Martian rocks and sediment samples that include a coring drill on its arm and the rack of sample titanium tubes in its chassis. Throughout its exploration of the region, the rover will collect promising samples, sealing them in tubes and storing them in its chassis until rover deposit them on Martian surface to be retrieved by the future mission. Perseverance will likely create multiple depots later in the mission for the purpose increase the likelihood that especially valuable samples will be accessible for the retrievals. Two science instruments on the robotic arm of the rover are used to analyze the chemical, mineral, physical and organic properties of the Martian rocks in order to look for the evidence of previous life and pinpoint sample collection location. Two sensors on the rover's mast offer three different types of spectroscopy and high-resolution imaging for accessing rocks and dirt at the distance. These tools also aid in selecting which rock target to investigate in closer details. With two upgrades that allowed it to land in more difficult terrain, the Perseverance rover utilized the same sky crane landing system as Curiosity did, allowing more harsh locations to be considered safe landing prospects. Subsequent NASA missions, in cooperation with ESA, would send spacecraft to Mars to collect these sealed samples from the surface and bring them back to Earth for the deep analysis using powerful laboratory tools too large to take to the Mars. The rover has been testing the AI for exploration of the Mars to find essential minerals and rocks for study for the past 3 years or so. At the moment, in the latest update, when Perseverance arrived at Bright Angle, the rover discovered peculiar textures resembling popcorn. It was thrilling to witness all the fascinating characters in the rock of this interval. These rocks, in the particular, are abundant in veins and nodules. Mineral crystals in the shape of thin plates and sheets that cut through rocks and intersect other veins are known as veins. And veins stand out in raised relief because they are frequently more resistant to erosion than the rock in which they are found. Small spherical protrusions in the rock are called as nodules. Nodules are frequently places where minerals have formed that are different from the nearby rocks. When water passes through the rock, vein and nodules are created, and the mineral in which water crystallizes is the crack and voids in the rock. Such features were before noted by Perseverance in its study of the western fan sedimentary strata, especially in the course of fan front campaign at Hogwallow Flat. In order to obtain high-resolution geochemical data on these rocks and to examine the abrasion patch in the further details, proximity science tools were used. The PIXL instrument is scanning with its head pointing down at the rock surface. NASA rover used two instruments, AI and the PIXL, for the detection and analysis purposes. These tools help to determine the best places to drill and collect samples. NASA's Jet Laboratory in South California is responsible for developing the sensor known as PIXL. In order to determine the chemical makeup of the mineral and rock samples, PIXL is utilized to provide vital information. The spectrometer, dubbed PIXL, is positioned at the tip of the robotic arm and is fastened to the 6 tiny robotic legs or hexapods. Legs are used for precise stability and control, which aids in placement. Accurate alignment is ensured by the PIXL instrument camera, which continuously measures the separation between it and a rock target. With a function in the sensor called adaptive sampling, which shows the historical circumstances of the Martian terrain, AI role on the Mars goes beyond Perseverance. NASA's Curiosity rover, located 2,300 miles away, has invented a different type of artificial intelligence that allow it to autonomously target rock with a laser based on their shape and the color. After that, it look at the target's PIXL scan to identify which mineral need more research. It's incredible that all of this occur in the real time, saving the rover from needing to communicate with mission controller back on Earth. The rover's greater autonomy, which allow it to make snap decisions and immediately gather crucial data, greatly improve the efficiency and success of its scientific research. The idea behind PIXL's adaptive sampling is to help scientists find the needle with the haystack of data, freezing up time and energy for them to focus on other things. To assist with positioning, PIXL's camera measured the distance between the device and rock target several times. Mars have significant temperature variations which can cause rover's arm to swell or contract minutely and interfere with PIXL's aim. Without making touch with the rock, the hexapod automatically modifies the instrument to get it incredibly near. Once PIXL is in its position, another AI system gets the chance to shine. PIXL scan a post-stamp size area of rock, firing an X-ray beam thousands of times to create a grid of microscopic dots. Each dots reveal information about the chemical composition of the minerals present. Minerals are essential for providing important answers regarding Mars. Depending on the type of rock, scientists may be searching for phosphates, which, if any, could have served as a food for bacteria that may have existed in the past on the Mars, or carbonates, which may contain hints about how water may have produced by the rocks. Scientists are unable to predict in advance which of the hundreds of X-ray jabs will reveal a certain mineral, but when the device identifies a particular mineral, it is automatically paused to collect additional data, a process known as a long dwell. The list of minerals that PIXL can focus on for an extended period of time is extending as the system becomes more intelligent through the machine learning. PIXL is kind of Swiss Army knife in that it can be configured depending on what the scientists are looking for at a given time. Using PIXL, which uses X-ray to analyze rock to identify the mineral makeup, NASA's Mars rover captured these images of rock target known as Thunderbolt Peak. Every blue dot in the picture indicates the location of X-ray impact. One of the NASA's Mars Rover 7 instruments, the PIXL, need image of rock targets in order to position itself autonomously. PIXL is designed to capture the night vision image of rock targets by encircling its aperture with light diodes. Pixel examine the chemistry of features as small as a sand grain using a concentrated X-ray beam. Rocks that are exposed to this tiny but intense laser illuminate. The laser is not apparent to the naked eyes, but the device can detect it, and its intensity changes depending on the elemental chemistry of the rock. After an overnight scan, Pixel scan the beam across the rock surface to create a chemical map of the material the size of the postage stamp. In addition, Pixel is managed with an optical physical system that uses a pattern of red laser and white floodlights to illuminate the rock while its camera records photographs of the mapped regions. These lights are visible on the rock in an artistic designs. In order to determine the target's location in the 3 dimensions and to maneuver itself into the ideal position for data collection and instrument security, PIXL examine them while in flight. In order for scientists to determine the precise location of each measurements, the images are also downlinked to Earth. This makes it possible for scientists to precisely correlate rock texture with chemistry, which aid in the investigation of the formation process and biological origin of the traits. It uses artificial intelligence to calculate the distance from the target to the scanned based on the photos. Future missions will be separated from Earth for a longer period of time than those that are currently on Mars when they venture deeper into the solar system. More autonomy for mission while they travel and do out research for the good of humanity is therefore highly desired. One of the main goals of Mars mission is astrobiology, which include looking for evidence of extinct microbes. In addition to paving the path for future human exploration of the red planet, the rover will define the planet's geology and historical climate. It will also be the first mission to gather and store Martian rock and regolith. NASA's Moon to Mars exploration strategy, which includes the Artemis moon mission to assist get ready for human exploration of Red Planet, include the Mars 2020 rover's mission. An ambition of some scientists is to use smart spacecraft to explore planet, ones that are precisely aware of what data to seek for, where to locate it and how to interpret it. While achieving that goal will require time, developments with NASA's Mars rover provide encouraging first step. The space organization's ongoing research and development is constructing a smart space exploration future wherein autonomously operation smart spacecraft will get closer to the organization's goal of better understanding Mars. The main goal of sending highly intelligent and autonomous spacecraft to explore planets is becoming a reality, and those developments in AI are essential steps in that direction. Thanks for watching video. Please like, share and subscribe my YouTube channel for more informative videos.